What?
They got a little bit on it.
Well, it was a spreadsheet, right?
Yes.
I didn't study. I didn't study. Is the bio quiz today?
You watched the and then this. But it feels the same way. The energy level. So it's like 1S, 2S, 2P, 3S, 3P, 4S.
A fermentation.
There were
like three questions.
Lactic acid or alcohol?
It's this.
There were like three questions. One was like explain
That was like, that was be like against the electrical gradient.
Ah, you're funny.
No, it was the course.
So it's like active transport, but electrons. It's passive transport. Oh, it goes with. Yeah, it's valid.
That was again.
But the core is the one that lasts.
Wow, that is also very funny.
I'm gonna take your spot.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Yes, hand me up Monday.
Guys, listen up for a second. This week, there's a Kids for Kids donation drive for benefiting the women's shelter, Veterans Women's Shelter. I know my wife, she teaches out at Medina High School, and they do something similar for their Latin club every year. It's a worthy cause, but if you can, if you think about if you're interested in doing this, you want to bring in either monetary donations, or they're suggesting things like tissues, Purell, sanitizing wipes, disinfectant wipes, chapstick, Ziploc bag, gallon Ziploc bags, napkins, toilet paper, paper towels, thermometers, women's sweatpants, sweatshirts, slippers, socks of any sizes. Anyway, it's up here in case you are interested in doing something like that, so think about it. Okay, so we had a homework assignment, a rather sizable one. You had to go ahead and do worksheet 6.3 to wrap up our discussion of stoichiometry in preparation for the test on Friday. A reminder to you that you do not want to blow off the theory. Make certain that you're okay with all the vocabulary and any theoretical considerations. There's not a lot, but there's enough to stop you from getting an A, even if you solve every problem correctly. So, 6.3, does anyone have any questions? Like to see the rationale or any of these worked out? I have a question for you. Did you do this worksheet without use of anything other than a calculator and periodic table? If the answer to that is no, that is not a good thing, guys. We needed to get to the point where we can do that. That was the whole point of giving you 3 of these worksheets, so that by the time you get the 3rd one, you were basically flying solo without a net. Because come Thursday, that's exactly what you'll be up against. Obviously, if you did not do that, you want to go back and revisit trying these out again. I would say that's not a bad idea to redo a few of these. You can see that there's a lot of similarities, but I would just maybe, actually try a few of try some of these again the night before the test. It's not enough, trust me when I tell you, just to look it over. Okay, there's no substitute for actually doing them again yourself. Any questions? So we're good, we know what we're doing, it's just a question of making sure we're all set for Thursday. Okay, if no questions, then let's go ahead and turn our attention to the worksheet. Well, actually, the worksheet exercise on page 7 of the electron instruction periodic trends. This is broken down into 2 parts. The first part was to ask you to go ahead. By the way, Nova, Eric, did you find out you had to predict oxidation states for lead?
No.
No?
I just did the ones on the paper.
Where were the people who were going to text you?
Yeah, Michael.
all your friends who were going to text you, they all assured me that they would text each of you.
They even asked you for the answer.
Okay. We wanted to do lead as well. Okay, guys. For lead, actually, we'll cover that first. Let's do the electron core configuration section first. So you had to write the electron core configuration for a variety of elements and ions. I gave you the key for this so that you could check over and see how you did. Do you want to see any of these worked out in terms of how I came up with the answers, or are you good to go? Do you understand what to do? Kyle?
Yeah.
You're okay? Hunter? Maria? Alexa?
Why is, for copper, why is it 3D10 instead of 3D9 and 4S2?
Okay, so copper, looking at it, is argon core. And as we look at it, this is 4s2, and if we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like it's 3d9 4s2. But remember, we talked about this last, what?
Like one valence one.
Right. We talked about the fact that having a half-filled D or filled D is so incredibly stabilizing that it's actually worth it. It's energetically favorable for this to sort of steal an electron from the S in order to complete the D sublevel.
Okay.
So copper family, chromium family and copper family, we see this deviation. It's the only deviation you're responsible for. There are other deviations. Some of you may have anticipated, well, what about the Fs, a filled F and a half-filled F? Do we see things like there are other deviations, and they get kind of weird as you go further down, so I'm not holding you accountable, but these two deviations you're responsible for, and that means you have to be on the lookout for these. Okay, these three elements right here, they're going to be D5S1s, okay, not D4S2s like you would expect, and the same thing with the copper family is going to be D10S1s. So that's why we know that this is argon core 3D10 4S1.
Okay, I thought that was like just like the first oxidation state automatically.
No.
It's
This is
before
neutral copper.
Okay.
This is neutral copper. So now, since they're asking you not for neutral copper, okay, if they ask that would be the answer for neutral copper. They're asking for the copper plus 1, okay? So whenever we remove electrons, they come off not necessarily the same way they went on, okay? For instance, the 3D electrons are coming in after the 4s, but once the electrons go in, the energies change. You don't have to worry about that. All you have to understand is if you put your electron configuration in final form, your electron core configuration in final form, when you remove electrons, just remember to remove them going from right to left. So the first electron that comes off is going to be the 4s electron. And that also explains why this is a stable species, because it has a filled D.
Excellent.
Joe?
For copper, predicting its oxidation states.
Okay, just hold. Well, before we go there, we're just on that first section, number 1, where we're just writing the electron core configuration. So we're not going to get to the predicting oxidation states yet. Questions? Everyone's so good on that section? Okay, all right, so let's go to the predicting oxidation states section. I'll work out each and every one of these or any of those that you want to see in terms of just the rationale. Remember that this is done on a mastery level per problem, and they're worth a fair amount of points, which means that if you start screwing up to any degree, you'll take a hit. This is usually where the wheels fall off for some people on this test. They'll just go through and do everything wonderfully, and then this section is where it just destroys them. All right, you had a question concerning copper.
Yeah, so for predicting copper, why wouldn't it also be Cu plus 6? Do you just stop if you?
Yeah, the idea, right.
Stop?
The idea. So he's talking about the fact that, okay, I've removed 1 electron. I can see why this is good. If I remove 5 more, so a total of 6 electrons, that would leave me with a half-filled D. The idea is that there's just no extra stability to be gained there. If you hit a noble gas configuration, for instance, to stop trying to lose. Why would the atom try to lose any more? It has a noble gas configuration. I mean, even if it could get to one of those other semi-stable states. Well, that's just it. They're semi-stable. And the next best thing to a noble gas is having a filled D in your outer energy level. So when you hit a filled D, this is why I say the rules for losing electrons is you stop losing whichever one you hit first. Either you have run out of electrons. Elements in row 4 and above can lose how many? 7, and those in 5 and below can lose 8. All right, so that's when you stop if you run out of electrons, or if you hit a noble gas configuration, or if you hit a filled D. Since we hit a filled D, we're done. All right, to account for the +2 state, which is actually fairly common in copper, more common than the +1 actually, and a fair amount of stability, we have to go to crystal field theory to account for it. And so you're not responsible. I would not expect you to predict that at all. Yeah, and actually requires more than I've even explained as far as crystal field theory to understand why that one works, because it doesn't work based on what we talked about last Friday. Other questions? Abby?
So can its original state, so when it's neutral, can that be an oxidation state as well?
Yeah, when I ask you, if I understand your question correctly, and if I don't, just let me know. Her point is that when I ask you to predict oxidation states for the elements, obviously every neutral element out there, I mean, it exists, okay? And some are more reactive, less stable than others, but they all have a neutral oxidation state. They all have an oxidation state of 0. When I'm asking you to predict oxidation states, you're going to be giving me besides 0. Is that what you're asking?
Yeah.
Okay. Yeah, you do not have to include 0 in your list of oxidation states. That's a given. Other questions? How'd we do on this? Yeah? Okay. Didn't miss one? If you did miss one, you know what you missed. You know what to watch out for. Remember, the big thing to do is after you write out that electron core configuration and box it off, what do you have to do, Alexa?
See if it's a metal or not.
Yeah, that's a big deal, guys. You got to know whether you're going to be losing only or losing and gaining. Yeah, you'll notice that for lead, I didn't give you the oxidation states, so let's go ahead and list those out. So for lead, you came up with what oxidation states, Hunter?
Lead. I messed up on this one, I didn't write it in final form.
Okay. Well, while you're figuring out what it is you messed up and coming up with your answer, that'll give Nova and Eric a chance to check their answers and everyone else to verify that they think they're right on what they got. Yeah, oh, by the way, Abby, argon, to your point, that's the only thing you could predict.
Yeah.
Yeah.
So would it be lead +2 and then lead +4?
There you go.
Filled S and a filled D.
Filled S and because you're going to be stopping at a filled S and stopping at a filled D. Correct. Those are the 2 oxidation states and the only 2 that you should have come up with. And if you look at the periodic table, oh yeah, that's kind of in keeping with what we know about lead anyway. Okay, plumbus and plumbous ion. Good. Questions at all? Yep.
For non-metals, when you're losing electrons, do you lose the same number, like 7 and 8, as you would with normal metals? Can you lose the same number?
Yeah, the number of electrons, same rules apply for the nonmetals as they do the metals as far as losing electrons is concerned. Correct. Other questions? All righty, well, if you have no other questions, then it's a big day today because we are going to look at the other half of the chapter starting today. And what we talk about today, guys, if you understand it, you can understand the rest of this chapter. I'm